to finish up 6-5 with operations on radicals. In this video, we are going to be able to simplify radicals by adding, subtracting, and multiplying. And some of this we did in class, and some of you haven't seen this at all, so feel free to fast forward if you'd like to. One thing to keep in mind when you're simplifying, or when a radical is in simplified form, the following conditions are met. So n is as small as possible, okay? The smallest n that you can have. The radicand, which is inside your little radical sign, has no factors other than 1 that are the nth power of the integer or polynomial. So for example, if you left your answer as the square root of 32, I'd mark that wrong because it's not simplified, because you can simplify it into the square root of 16 and 2, which is 4 square roots of 2. Okay? The radicand has no fractions involved. So again, if you have the square root of like x over 4, can't leave it like that. You got to simplify it as the square root of x over the square root of 4. Okay? And no radicals appear in the denominator, which we've known that for quite some time.
Hi, Ms. Davis.
Hi. What's up? Okay, sorry about that. So when we are simplifying, we can go ahead and take 5 times 3, because they're on the outside here. That's going to be 15. And then whatever inside the radical, we can go ahead and combine those. So negative 12 times 18 is a negative 216. Then we have a times a squared. It's going to be a cubed. And then we have b to the 4th times b squared. It's b to the 6th. So when we do this, we have 15 times the cube root of a negative 216 actually comes out nice. It's a negative 6. The cube root of a to the 3rd is a. And then the cube root of b to the 6th is b squared. So we can go ahead and put these together. 15 times a negative 6 is a negative 90. So we have a negative 90a b squared. And that's our answer. Okay, let's look at this next one. So we have 2 and 3. We can times those together. And then we have the 4th root of 8 times 2 is 16. X to the 8th, y to the 4th. The 4th root of 16 is 2, so we have 6 times 2. And then we have x squared, because the 8th, x to the 8th, the 4th root of that would be squared. And then we have the 4th root of y to the 4th. Got to be careful here. We have an even, and then an even, and we end up with y to the 1st, so it's an odd, so it has to be an absolute value bar, so even, even, odd. So our final answer should be 12x squared, y in absolute value. All right, now we're going to move on to adding and subtracting. Now when adding and subtracting radicals, you can only combine like terms. So they have to look the same. Just like with fractions, just like with variables, they have to look the same. And these do not look the same right now. So let's see if we can simplify these to make them look the same. So square root of 98, is there a perfect square that goes into 98? Yep, 49. And then 32. 16, yep. Oops. 16 and 2. So it looks like we're going to have 7 square roots of 2 minus 2 times 4 square roots of 2. Hey, now they're looking more alike, the square root of 2 and the square root of 2. So we have 7 square roots of 2 minus 8 square roots of 2. Our final answer is going to be a negative 1 square root of 2, or you can just write it as a negative square root of 2 as well. All right, let's try the next one. Why don't you pause the video and see if you can do this one on your own. And yes, it's blurry, it's not just your eyes. All right, so you should think to yourself, how can you simplify this? The square root of 8 is going to be the square root of 4 and the square root of 2. So we have 4 times 2, square roots of 2. Square root of 50, we have 25 and 2. So that's going to be 3 times 5, square root of 2. Now they look alike. So 4 times 2 is 8 plus 15. So 8 square roots of 2 plus 15 square roots of 2 is going to be 23 square roots of 2. And that would be your final answer. Okay, now multiplying. So when you multiply, we're going to be foiling here because we have a binomial times a binomial. So we're going to take the first term. So we're going to take 4 square roots of 3 times 3 square roots of 2. And that's going to end up being 12 square roots of 6. That's our first term. Now we're going to go to our outer. It would be 4 square roots of 3. That's a positive 4. Times a negative 6. So 4 times a negative 6 is a negative 24. So we have a negative 24 square roots of 3. Now we're going to go inner. So it's going to be 15. Oh, I should probably write it all out, huh? Sorry about that. So we have 5 square roots of 2 times 3 square roots of 2. And it looks like when we have the square root of 2 times the square root of 2, that's just going to be the square root of 4. So that's 2. So this is actually 15 times 2. So it looks like we're going to have plus 30. And then we take the outside, or the last terms, and that's going to be 5 square roots of 2 times a negative 6. So that's going to be a negative 30 square roots of 2. Now, is there anything we can combine here? Square root of 6 can't be split up. Square root of 3 can't be. Square root of 2. Nope. They all look different. So guess what? This is our final answer. Alrighty. So here's the next one for you. I want you to do in the Google form below. That's how I'm going to check to see if you did your notes. Watch the first video if you need to again. And yeah, my hint to you is that, well, you don't need a hint. I want to see what you get. I want to see what you get. So you guys have a good day. And we'll see you later. Come with lots of questions.